record here. Total number of socks. He bought some wool socks. He bought some cotton socks. The total was 8 pairs. So it looks like almost everybody that has responded so far correctly said that we should have an equation that W plus C is 8. The number of pairs of wool socks plus the number of pairs of cotton socks needs to have a total of 8. So W plus C, the total is 8. Okay. Now we also have the cost. Okay. Total money paid. He paid $4 per pair for the wool socks. So if you pay $4 per pair of wool socks, you got to take the number of wool socks you bought and multiply it by 4. Per was the one of the things that I mentioned yesterday that indicates you're going to multiply. When something is per item or for each thing, that's going to be multiplying. $4 per pair of wool socks. Now the cotton socks are $3 per pair. So $3 per pair of cotton socks. The total money, this is the money on the wool, this is the money for the cotton socks. The total money is 27. Okay, so that's what our two equations, our system looks like. So the first equation, total of 8 pairs of socks. Second equation, total of $27 money spent. And that money comes from $4 for every wool plus $3 for every pair of cotton socks for a total of 27. Okay? Yeah. Now for solving, you could solve by graphing. You could also solve by substitution. If you wanted to substitute, I would take this equation and solve it for like W equals, because you could do that pretty easily. You could also use elimination. So it's really up to you, the method that you want to use to solve this system. My tendency is that when you have a system set up where you've got all the variables lined up, so I got my W's lined up, I got my C's lined up, I got my equal signs lined up, I got my numbers lined up, I kind of like to do elimination because I think elimination is a really cool method and it works especially well when everything is lined up because I don't have to rewrite anything. I don't have to rearrange my equations. I might have to multiply my equations by something, but I don't really have to change and rewrite the way that these equations are written. So I think that's what I would like to do, which is called elimination. And I'm looking at our answers. Good. Oh, good. I'm going to turn off the response form and let's take a look here. So W's, C's, we need to eliminate one. So which one do you guys want to eliminate, W or C? W. Okay, to eliminate W, this is a positive 4. I need this one to be a negative 4. So I'm going to multiply this equation by negative 4 because that will give me a negative 4 in front of the W, which will eliminate with this positive 4. So equation on the top, negative 4W minus 4C, because a negative times a positive, equals negative 4 times 8 is negative 32. Second equation I'm going to leave alone. Okay, my W's, they eliminate. That's the whole reason we did this. Here I'm going to add straight down. I got negative 4 and positive 3. You add those, you get negative 1C, or just negative C, equals, right here, negative 32 plus 27 is negative 5. You divide both sides by negative 1, we get C equals 5. Okay. Make sure your answer makes sense. We're trying to figure out C, the number of pairs of cotton socks. So yes, you can buy 5 pairs of cotton socks at a store. You cannot buy a negative number of pairs of socks. You cannot buy 2.7 pairs of socks. So the only way you can buy socks at a store is full pairs of socks. They won't split them and just sell you, half a pair and give you 1 sock. You got to buy them in pairs. So 5 is a reasonable answer. Now for the wool sock, I've got this really cool equation right here. I know he bought 8 pairs of socks total. I know that 5 of them were cotton, so you can probably figure out by mental math that means he had to buy 3 pairs of wool. That's the only way to get a total of 8. If you buy 5 pairs of cotton, that leaves 3 pairs of wool socks for a total of 8. Now, the last thing you need to do with a word problem is answer the question. And the question is, how many pairs of socks did Manny buy? So Manny bought 5 pairs of cotton socks and 3 pairs of wool socks. So that is the answer. I know we talked about systems, saying that we always write the answer to a system as an ordered pair. The one exception to that is when it's a word problem. If you were to tell me that my answer is like, 3, 5, okay, technically, yeah, that's a point on a graph, but it doesn't answer the question. If someone said, how many pairs of wool and cotton socks did Banny buy? And you wrote down, he bought 3, 5, nobody knows what that means. Okay, so don't write an answer like that when it's a word problem. Make sure that if your problem is words, your answer is words. So 4 things that you would need to have here. Number 1, you need to define your variables. Number 2, you need to write a system of equations. That means 2 equations. Number 3, you need to solve the system. And number 4, you need to answer the question, which will require a sentence. It'll require words. Okay? So that is the warm-up. And what we're going to do is take notes on this exact same thing. So we started off looking at word problems yesterday by looking at the different ways that we could write different equations and expressions. But if you go to the next page here, this is the type of thing that you're going to need to know for the test, which is basically the Manny type of problem. So the problem that we just looked at on the warm-up, Manny and his socks, is the type of thing that you will need to know for your test next week. This problem here is also that type of problem, as is the next one and the next one. So we got 3 problems that we're going to go over today on our notes, and they're all going to be the types of problems that you will need to do on your test. So like that graphing thing on Delta Math, it's cool to know that you can solve like that, but it's not very practical that we can actually test you to do that. So you can't really show me when you're testing that you know how to draw those lines and stuff, but this you can. So this is what the word problems are going to look like on your test, which for you guys in here is Friday. For those of you online, your test is Thursday. So Thursday and Friday. So Mr. Seffens, you don't know Mr. Seffens, he is next door right now. He is a candy connoisseur. That means he loves candy. So he bought several bags of caramel candy and several bags of taffy to meet his craving for sugar. The number of bags of taffy was 5 more than the number of bags of caramels. Some people say caramel, some people say caramel. They're both correct. Taffy bags weigh 8 ounces per bag, and caramel bags weigh 26 ounces per bag. Total weight of all the bags of candy was 380 ounces. How many bags of candy did he buy? So first thing we need to know is, what is it asking? How many bags of candy did he buy? And we know that he bought caramels and taffy. So we really got to figure out, well, how many bags of caramel did he buy? How many bags of taffy? So our first thing is to create a let statement. That means we need to define which variables we're going to use. So something in the chat there. Okay, so caramel, taffy. You can use any variables you want. X and Y is fine, especially if you're going to graph them. X and Y is a good choice. I'm not going to graph them, so I'm going to use C for the number of bags of caramel. And the reason I like to do that is because then it's very clear as I'm solving which thing I'm solving for. So since the two things that are missing in this problem are the number of bags of caramels and the number of bags of taffy. So I will use T for the number of bags of taffy. So it'll be very clear to me what we are finding. So those are the two things that we need to find. Step 2, we need to write two equations. We have two variables, so we're going to need two equations. Now, my first equation comes from the information I have here about the taffy and the caramel. So highlighted there in yellow, the number of bags of taffy was 5 more than the number of bags of caramels. That's literally an equation right there. Number of bags of taffy, that's T. It says so right here. Look, that's number of bags of taffy. So number of bags of taffy is T. Okay. Was or is an equal sign. So number of bags of taffy equals or was. So the number of bags of taffy was, and then we just have to do this. 5 more than the number of bags of caramels. C is the number of bags of caramels. So we have to do 5 more than C. 5 more than C is you add 5 to your C. C plus 5, 5 plus C, same thing. It doesn't matter the adding order here, but you got to take your number of caramels and add 5. So this literally says the number of bags of taffy was 5 more than the number of bags of caramels. That's that yellow sentence is literally that equation. We just translated the words into mathematical symbols. Now, the other thing that we are told about this candy, we are told about the weight. Taffy weighs 8 ounces per bag. Caramel, 26 ounces per bag. And total weight is 380. So we have information about the weight. So taffy bags, 8 ounces per bag. Per means multiply. Taffy is 8 ounces per bag. So I'm going to multiply 8 times the number of bags of taffy. Caramels, 26 ounces per bag. So I'm going to take my caramels and multiply that by 26. 26 ounces per bag of caramel. Total weight, so I add my weights together because that's what total means. You get totals by adding things together. The total weight was, there's that equals again, 380. Okay, so there's my two equations. So number of bags of taffy was 5 more than the number of bags of caramel. Each taffy weighed 8 ounces. Each caramel weighed 26 ounces for a total weight of 380. Now I have this system. You can solve by graphing if you want. You can solve by elimination if you want. I personally would choose substitution because, look, it says T equals right there. If T equals C plus 5, the easiest way to solve this is to just put the C plus 5 in place of the T. You couldn't solve it any of our methods. All of them work. But sometimes one method is easier than the other depending on how the equations are set up. So when you have a t equals like that, personally, I believe substitution is the most straightforward way to do it. So c plus 5 is going to go right there where the t is. So I'm going to put in a c plus 5. I am going to distribute right here and here. So 8c plus 40 plus 2c equals 380. If I add my c's together, 8 and 2, I get 10c. And then I have this 40 that's on the wrong side of the equation. So I'm just going to move that 40 over to the other side by subtracting. And notice that I get 3. Oh, wait a minute. I wrote a 2c here, and that is wrong. This was 26. Sorry about that, guys. So this is 26c. I, for some reason, decided to just drop my second digit there. So 8 plus 26 is 34c. And then subtracting here is 340. So sorry, no mistake there. Okay, now if I divide, I get c equals 10. I knew it was wrong because I was going to get a very unreasonable answer there. He was going to end up buying like 100 bags of caramels, and I'm pretty sure that he did not. 10 is a reasonable answer. So he bought 10 bags of caramels. Taffy. What do we know about taffy right here? He bought 5 more bags of taffy than he did caramel. It says to figure out the taffy, you take your caramels and you add 5. So if I take 5 and add it to that, just mental math, I can figure out that taffy is 15. So he bought 10 bags of caramel, 15 bags of taffy. Don't forget to answer the question. So he bought 10 bags of caramels or caramels and 15 bags of taffy. Okay, you want to check your answer? There's 2 things that need to be true. The number of bags of taffy needs to be 5 more than that, and it is. And the other thing is that the weight needs to come out to 380. So you can check 8 ounces for each bag of taffy. So multiply that by 8. 26 ounces for each bag of caramel. So multiply that by 26. Total weight should be 380. Okay, so you guys can check that when you're doing these as well. Okay. On Monday, I bought 10 cups of coffee and 5 donuts for a cost of $16.50. Brought them to school. Turns out people like the donuts more. So it turns out the donuts were more popular than the coffee. So the next day, I switch it. I buy 5 cups of coffee and donuts. This time I spent $14.25. So the question that we need to answer, how much was each cup of coffee and each donut? So we need to know how much each one of those things cost. So first, figure out what it's asking you to find. Going to be 2 things that you need to find. So first thing I need to find is how much was each cup of coffee. So I can let C equal the price, how much means price, of a cup of coffee. Be clear right here. Don't just say C equals coffee. Well, what about the coffee? It's not how many. I know how many I bought. Here I bought 10, and here I bought 5. So we don't need to figure out how much coffee I bought. We know how much I bought. 10 on one day, 5 on the other. So don't say C is how much coffee I bought, because that's not what we're looking for. We're looking for how much. That's the price or the cost. So right here, it should say price of coffee or the cost of coffee. And we also also need to find the price of a donut. So the price of a donut. Okay. Now we need to go to our problem and figure out, what do we know? Well, we know 2 days worth of information. On Monday, 10 cups of coffee and 5 donuts will cost $16.50. So 10 cups of coffee and 5 donuts give me a total price of $16.50. So the total price, if you buy 10 cups of coffee and 5 donuts, total price $16.50. Now I went back to the store the next day and I changed it. So 5 cups of coffee, 10 donuts, cost $14.25. So 5 cups of coffee and 10 donuts cost $14.25. There's our system. So our system in this problem represents each trip to the store. So this is what happened on Monday. This is what happened on Tuesday. So the 2 pieces of information are the 2 different purchases. So 10 cups of coffee multiplied by whatever the price is, plus 5 donuts multiplied by whatever the price is, for a total price of $16.50. Okay, I'm going to do elimination on this, because again, I like elimination when everything lines up. So what do we want to eliminate? Coffee or donuts? What are we going to get rid of? Make a choice. Donuts. Okay, to get rid of donuts, this is a 10. I can make that into a 10 if I multiply by 2. However, I really would like to make it a negative 10 because I like adding versus subtracting. So I always want to make it the opposite sign. So I'm going to multiply everything here by negative 2. So negative 2 times 10 is negative 20 times C minus 10D equals, that's what, negative 33. And then 5C plus 10D equals 1425. And then I add these 2 equations together, and look what's going to happen. My D's are going to disappear. That's the whole point. That's what we want to have happen. Adding here, negative 15C equals, I add there, and I'll grab my calculator to do that, because that's negative 33 plus 1425 equals negative 1875. Okay. Now, this is a case where a decimal answer is fine. We're trying to calculate the price of things. Decimals are absolutely fine when things are priced. You've been to the store before. Most things have a dollar and a cent. They have a decimal. So I'm going to take negative 1875 and divide by negative 15. So if I divide that, calculator will come in handy for that. I get C equals 125. That is reasonable. Coffee costs $1.25. That's a reasonable price for coffee. So it's not negative. It's not, like $20 or something unreasonable. So I'm pretty confident that that looks like it would be right. Now I need to figure out how much donut costs. So an equation. Now let's do this one. Okay, 5 cups of coffee plus 10 donuts has to equal 1425. So 5 cups of coffee is $1.25 plus 10 donuts equals 1425. So I'm going to multiply 5 times $1.25. That means I've spent $6.25 on coffee this day. And I bought 10 donuts, and my total price was $14.25. If we subtract we get negative, or we get 8. So 10 donuts cost $8. Divide by 10, and it's a fraction, but since we're talking about money, it would make more sense, like telling me this, even though it's technically correct, that's just weird. This is money that we're talking about. So I'm actually going to divide that and get 80 cents. Because that's actually a number that makes sense when you're dealing with money. So we now know coffee costs $1.25 and the donuts are 80 cents a piece. So coffee is $1.25 per cup, and donuts are 80 cents each. So that's what we figured out. And if you've ever been to a donut shop, that's a pretty reasonable price for coffee and donuts. Okay. So again, decimals generally are not okay if you're calculating the number of something, but it's absolutely fine for price. Okay, this is the last one we're going to do here. I know there's more on the next page, but we can save those for next week. Because as you guys might guess, this is what you're going to be doing tonight on your Delta Math assignment. So 4 steps. Define your variables. Write a system of equations. Solve it. Answer the question. And what are we doing here? Yeah, we got time for one more. We got 20 minutes left in class. Okay, a jeweler. Yeah. Yes. Okay. A jeweler had a fixed amount of gold to make bracelets and necklaces. The amount of gold in each bracelet is 8 grams. The amount of gold in each necklace is 24 grams. That's the weight of the gold that he needs to make a bracelet and a necklace. The jeweler made a total of 13 bracelets and necklaces and used 168 grams of gold. How many necklaces and how many bracelets did he make? So first thing, what are we looking for? How many necklaces and how many bracelets? That's what we're looking for. So we need variables for each one of those. So we could do B for bracelets and N for necklace. So number of bracelets, N equals number of necklaces. It's not the price, it's the number of, because it's how many. So that means my answers for B and N better be positive whole numbers. He's not going to make just part of a bracelet or a necklace, and he can't make negative bracelets or necklaces. So it's always good to make sure that we have an idea of what type of answer we're looking for. Okay, so what do we know? A couple of things. We know he made a total of 13 bracelets and necklaces. That is too dark highlighting, and you guys can't see that. So let's choose a color here. Here's a lighter pink. So total of 13 bracelets and necklaces. So a total of 13 bracelets and necklaces. B for bracelets, N for necklaces. A total of 13. The bracelets and the necklaces together totaled 13. The other thing we know is about the weight. So we know that a bracelet weighs 8 grams, or has 8 grams of gold in it, I should say. A necklace has 24 grams of gold in it, and the total amount of gold that he used is 168. So the second piece of information in this problem is the gold. So the gold for each bracelet, the gold for each necklace, the total amount of gold. So 8 ounces of gold for each bracelet, 24 grams of gold for each necklace, for a total of 168 grams of gold. So there is our totals. So total 13 items that he made, 168 grams of gold total. So now we want to eliminate or substitution. You really could do either one. If you like substitution, just subtract n from both sides and substitute. If you like elimination, like I like elimination, I just need to multiply that first equation by something. Okay, what should we eliminate? Bracelets, necklaces. Okay, I'm going to eliminate bracelets. Reason? That number's smaller. I only have to multiply this equation by 8 versus multiplying it by 24. So let's multiply this equation by 8. It's actually negative 8, so that way the negative 8b will eliminate with this one. So negative 8b minus 8n equals, and then I got to do negative 8 times 13. You see me using my calculator more today because these are some bigger numbers. Don't be afraid to use one. 8b plus 24n equals 168. We add these two equations together. The b's eliminate, and 24 take away 8 is 16n. And right here, 168 minus 104 is 64. Then my last step is to divide. If you divide 64 by 16, you get 4. So I now know he made 4 necklaces. I can do mental math here because I know he made a total of 13 pieces of jewelry. If 4 of them were necklaces, then I know that that makes 9 bracelets because these have to total 13. And you can sometimes just do that mental math like that if one of the equations is super easy. So if you got a super easy equation like that, it's okay to just do mental math on it. So how many necklaces and how many bracelets did he make? Let's answer it. He made 4 necklaces and 9 bracelets. Okay, so again, that is what you're going to see with a word problem. Figure out what variables to use. Set up a system. Solve the system. Answer the question. So 4 things that you need to do in here. Figure out what variables you're using. Use them to create a system of equations. Solve your system. Elimination, substitution, or graphing. You got 3 methods that you can choose. But then do make sure you answer the question over here. So the question is, how many did he make of each one? So make sure that you actually answer that. Yeah, if you look on your Delta Math for tonight, you'll see that you are doing basically this. They're all very similar to the ones that we went over in class. So please, access your notes to help you. There's the videos on Delta Math that can help you as well. And like I said, if you're having trouble or struggling with any of this, let me know. I will invite you to office hours today at 2:40. I don't have office hours on Monday because it's an articulation day, but I will have them again on Tuesday. So let me know that you would like to attend office hours. It's via Zoom because you're already home by 2:40. So, just let me know. I've got, I think, like 6 people signed up for today. So we'll just go through and do more sample problems. I just do them, online with everybody. Okay. So any questions, please let me know. Okay, we've got about 15 minutes left in class. And let me check what's in the chat here. Okay. Question on the chat was, will the test be all word problems? And the answer is no. It will not be all word problems. This is just one of the things that we have done this chapter. So at most, maybe 2 word problems, if even that many. There'll definitely be at least one, but it'll probably be one or two. So you need to know how to solve by graphing. You need to know how to solve by substitution. You need to know how to solve by elimination. And you need to know how to solve word problems, but no, this is not the entirety of the test. So if you know how to do everything else, could you pass the test without doing this? Yeah, but you wouldn't get an A. So it's better if you do know how to do it, but no, you don't have to worry about this being the entire test. Okay. And